Okay, Algebra 1, you should have your pencil and a calculator. The substitute is going to pass out your notes for today. Please pay attention and follow along. If you need to pause the video, if I'm going too fast, please ask the substitute politely. Be on your best behavior. After you finish the notes, the substitute will pass out your assignment, and you can get started on it at the end of class and then finish it for homework. Okay, so if the substitute has passed out your notes page, you're going to take the top and fold it down to show the titles, and you should see polynomials and then degree and name on the top, and then fold the bottom up to show the titles adding and subtracting. So after you folded the top down and the bottom up, it should look like this. Later, you can use scissors to cut on the lines between polynomials and name and degree and adding and subtracting. Right now, you can just leave it like it is. Okay, so we're going to start talking about polynomials. So this is on the upper left-hand side if you open up the foldable. So a polynomial is a monomial or the sum of monomials, each called a term of the polynomial. A binomial is a polynomial with two terms. A trinomial is a polynomial with three terms. So polynomial just means like an algebraic expression. When we write several things added or subtracted together, that creates what we call a polynomial. So an example of a monomial would be like 2x squared or 5 or y to the 5th power. If it's just one term, nothing is being added or subtracted, it's a monomial. A binomial is going to be two terms that are being added or subtracted. So like 5 minus 2b or x minus 5. Anything with two terms being added or subtracted. A trinomial has three terms. So one example could be x squared plus 5y minus 3. It doesn't matter the combination of letters and numbers. It's three terms separated by plus or minus sign. So all of those are examples of polynomials. When we have a monomial, binomial, or trinomial, we say those specifically. Anything more than three terms, we just call a polynomial. Okay, the standard form of a polynomial has the terms in order from greatest to least degree. The coefficient of the first term is called the leading coefficient. So if I'm going to write a polynomial in standard form, I'm going to start with the term that has the highest exponent. So this is an example of standard form. 5x to the 4th power minus 3x to the 3rd plus 10x squared minus x plus 5. So if you look at the exponents, they start with the highest exponent for the first term, and then they go down by 1 each time. Now, they don't have to have all this exponents that go down by 1 each time, but you always start with the highest and work your way down to the least. The leading coefficient for this polynomial would be the 5 that's in front of the x to the 4th power. Okay, next we're going to talk about the degree of a polynomial and how to name it. So the degree of a monomial is the sum of the exponents of all of its variables, and the degree of a polynomial is the greatest degree of any term in the polynomial. So I'm going to put a couple of examples here. So here is a monomial because there's nothing being added or subtracted. It's just one term. 5x squared y to the 3rd power. So because there are multiple variables here, we would take the exponents of those variables and add them together, and this would be called a 5th degree monomial. If you have a polynomial that has several terms, this is an example of a trinomial because there's 3 terms, then you're just going to look at the term with the highest exponent, in this case a 3, so this would be a cubic polynomial or a 3rd degree polynomial. Okay, so down below you have a chart that we're going to fill in, and I'm going to give you some examples for the degree and what the name of that polynomial would be. So if something has a 0 degree, that would look like 2x to the 0 power. And we know that anything raised to the 0 power is equal to 1. So it's like that x to the 0 disappeared, basically. So when that happens, you're just left with a number, then this is a constant term. If your term has a variable with an exponent that is to the 1 power, there's an understood 1 here with 3x to the first. So this would be called a linear polynomial. Okay, if the highest exponent is a 2, so 5x squared, this is a quadratic polynomial. If the highest exponent is a 3, like 17x to the 3rd power, this is a cubic polynomial. Highest exponent is a 4, like 1/3 x to the 4th power. This would be a quartic polynomial. If the highest exponent is a 5, like 2x to the 5th, then this is a quintic polynomial. Now, any degree that is 6 or higher, we're just going to say that it's a 6th degree polynomial or a 7th degree polynomial. Whatever the highest exponent is, 15th degree, you're just going to use that word instead of having a special name. Now, we could use that same terminology for a 3rd degree, 4th degree, 5th degree, but we just like the specific name of quadratic, cubic, quartic, etc. Okay, so now we're going to fold down to the bottom half of the foldable. We're going to look at examples of adding polynomials first. So when we are adding polynomials, that involves collecting like terms or adding terms that have the same variable and exponent. We can only add terms that have the exact same variable and exact same exponent. So as I'm going through these, I'm going to underline with different colors to show the different terms that I can add together. If you want to use colored pencils or if you want to mark them out as you go, whatever will help you out. So I've got 2 trinomials that I'm adding together. The parentheses in this case aren't really doing anything, so you can ignore the parentheses because there's no numbers in front that I'll need to distribute. So I'm going to start with the highest exponent, which is x squared. So I'm going to look at any terms that have an x squared. So like 2x squared and the negative 4x squared. Because those have the same variable and exponent, I can add those together. 2 minus 4 is going to be a negative 2x squared. Okay, then I go to the next highest exponent. In this case, it would be the 5x and the 6x. So 5x plus 6x is 11x's. And then all I have left are the constant terms. Negative 7 plus 3 will be minus 4. So if you always start with the highest exponent and then work your way down, you're always going to have your polynomial in standard form. That's how I like to do it. So here's my answer of these 2 polynomials being added together. And what I want to talk about also is the name of this polynomial. So the highest degree of this polynomial is 2, so that makes it a quadratic, and there are 3 terms, so it is a trinomial. So a quadratic trinomial. Okay, next up on example 2, we're still going to add. We have a trinomial being added to a polynomial. So again, I'm going to start with the highest degree and then work my way down. So I have y to the 4th and a negative 2y to the fourth. So 1 minus 2 will be negative 1y to the fourth. Okay, next would be to the third power. So I have a 2y to the third power and no other third power. So I can just go ahead and write plus 2y to the third. The next exponent would be y to the second power. And there aren't any terms in these polynomials that have a second power, so I'll skip that. Next are the linear terms. So anything with y or y to the first power would be negative 3y plus 2y. Negative 3 plus 2 will be minus 1y. And then last I have the constant term, 7 minus 11. 7 minus 11 is negative 4. So it helps if you're underlining or crossing them out as you're adding, so then you know when you've gone through all of the terms or not. So after you're done, always make sure they're in descending power, highest exponent first. Okay, so since the highest exponent for this polynomial is 4, this is a quartic polynomial. Anything more than 3 terms, we just call a polynomial. Okay, now we're going to go on to subtracting polynomials. So subtracting polynomials involves using the distributive property and then adding like terms. So the first set of parentheses, we're not going to do anything to those numbers in that parenthesis because there's not a negative in front. So I can just rewrite those set of numbers just like they are. Then the second set of numbers or terms that come after the minus sign, we're going to distribute the negative into those parentheses. So everything in that parenthesis is going to change sign. So when I do a negative times 3p squared, that's going to be minus 3p squared. Negative times positive 2 will be a negative 2. And a negative times negative 9 will be plus 9. So after you've distributed, now we're just going to add like terms. So again, I'm going to start with the highest exponent. For this polynomial, the highest exponent is p to the third power. So there's only 4p to the third power. Then I would go to anything to the second power. So I've got a negative 3p to the second power. And then p, or p to the first power. So I have a 7p to the first power. And then last should always be your constant terms. So I have a negative 8 plus 2 minus 2 plus 9. So negative 8 minus 2 plus 9 is equal to negative 1. So always double check to make sure you've collected all of your like terms. They should be in descending power. This would be a cubic polynomial because the highest degree is 3 and it has more than 3 terms, so we call it a polynomial. Okay, last example, number 4, we're going to do the same thing. Since the first set of parentheses doesn't have a negative in front, we're going to keep those terms just like they are. Then I'm going to distribute the negative into the second set of parentheses. So negative times negative 2h cubed is going to become plus 2h cubed. Negative times positive h squared will be minus h squared. And a negative times negative 2 will be plus 2. So now I'm going to go through and collect my like terms. I'm going to start with the highest exponent. So I'm going to start with the h to the third power. So I have a 4h to the third power plus 2h to the third power. So together that is 6h to the third. Then I have h squared, so negative 3h squared minus 1h squared will be minus 4h squared. Then my h's, I have plus 6h and no other h's. And last are my constants, negative 4 plus 2. So that would be minus 2. So again, because the highest exponent is a 3, this is a cubic polynomial. Okay, so that's all for the notes. The substitute's going to go ahead and pass out your assignment. When you get your assignment, you're going to see that the first 4 problems just ask you to name the polynomial by degree and the number of terms, and to write them in standard form if you need to. Questions 5 through 9 say to simplify the sum, then write in standard form. So you're just adding on 5 through 9. And then the last section, 11 through 16, you're finding the difference. So that means you're subtracting, or you're going to distribute the negative into the other parenthesis and then collect like terms. Make sure your answers are in standard form. So if you have class time now, you need to start your assignment. Whatever you don't finish is homework. Tomorrow at the beginning of class, I'll answer a couple of questions before we move on to the next section.